Well, thanks again, everyone, for having me. My name is Mike Metral, and I am an engineer at Pulumi, and I primarily maintain, I think it'll be easier like this. I primarily maintain our EKS installer, that is Kubernetes running on Amazon. And we also work with our Kubernetes provider, which allows you to not only manage clusters, but also deploy resources into those clusters. So I wanted to kind of just get a walkthrough going around how do you get started with Kubernetes using Pulumi. And it's really around how do you manage your clusters and your API resources in production. So let's kind of go over what we'll be reviewing in this session. So I'll go through a brief overview of what Pulumi is, kind of the basics and how to work with Pulumi. We'll cover production Kubernetes architecture, what it looks like to actually be running in production. Many of us have worked with many large customers globally to run Kubernetes in production at scale. So we've been able to bake a lot of these defaults and experience and knowledge into our tool set. And then we'll jump into demos. I'm hoping to have questions throughout the whole presentation, but if for need be, we'll be reserving some time at the end of the talk in case folks have any questions. But please feel free to drop something into the chat or raise your hand. So what is Pulumi? Pulumi really is a modern infrastructure as code tool that allows you to use imperative languages to describe your infrastructure. Many folks are used to kind of using a templating system such as say CloudFormation, maybe they're using JSON, YAML, or more often than not, maybe they're using like a DSL, like a Terraform. And in essence, right, the configuration management problem has been a burden, especially as the adoption to cloud expands, especially as your complexities around the architecture that you're deploying gains more resources. So really, it comes down to the fact that it just hasn't quite cut it to use the status quo. And we often reach for programming languages to help us in these necessities, right? Being able to manipulate resources as we see fit. And languages actually allow themselves to be very, very beneficial to these use cases. So Pulumi is the ability to use any language, your favorite language, right? We support JavaScript, TypeScript, Python, Go, .NET across many of the cloud providers publicly and on-prem as well. We have many providers that we can tap into. But the idea is that you can use imperative programming language to describe and declaratively instantiate your infrastructure. It's really about leveraging really languages, right? And what languages are meant to give us, but more so to just be more effective at managing this complexity. In this code sample, and you're right, this is actually an example of using Go on GCP to instantiate a firewall and a VM. And it's quite crazy that we have the ability, right, to use languages to do this. And it actually gives you more beneficial gains because off the bat, you're using what languages are meant to be doing, right? You can share best practices with your default package managers. You get type checking, linting. You have your IDE to help you out when you have errors as you're authoring your code. And more so, because it's code, you can do your usual audit reviews, your PR processes, your CI/CD deployments. All of this code for your infrastructure can be co-located or managed separately with your apps. It's up to you. But Pulumi is about leveraging these languages to your full extent across any of the major cloud providers. We are open source. We are Apache 2 license-based. We are free for community users for life. And where our business model starts is really around teams. But even then, we have the free SaaS that I'll get into in a bit as to how that works. And then we'll jump into some more demos of Pulumi and Pulumi with Kubernetes. So it's not only cloud native infrastructure as code, right, that you can describe. It's not just VMs and it's not just virtual networks and it's not just storage, right? All of these services are great and you're going to use them, but more so, right, Kubernetes has become the forefront in container management. And so we support Kubernetes as well. And if you've worked with Kubernetes, the standard is working with YAML, with JSON, with DSLs, with Helm manifests. And more so, this is even more convincing reason why, as the complexity of the API resource surface area kind of continues to grow in Kubernetes, it becomes hard to manage this with just general templates. And so there is no YAML, there is no JSON, there's no DSLs. It's your favorite language to declaratively work up to the infrastructure that you desire. Much like Kubernetes has these controllers that are in a control loop that are working towards a desired state, Pulumi operates in the same model, but using imperative languages to drive a declarative desired state. And so this gives us the convenience of a couple of things, leveraging imperative programming languages to manipulate and manage our infrastructures as we see fit, but more so allowing you to have the declarative aspects that you expect, such as previewing changes, diffing these changes, having rich status updates to see what's worked, what's not worked. Bubbling up errors is something we commonly do, so you don't have to go inject into working with Kubernetes. If you've worked with Kubernetes long enough, it's a game of playing, 21 questions with kubectl. Did my pod come up? Did it not come up? Let's see what events set up. Maybe there's a pod security policy that's preventing me. So a lot of this discovery, if you will, of errors as you're working with Pulumi, with Kubernetes in development, it becomes very nuisance. So it's not only a utility, right, to describe Kubernetes clusters and deploy resources into those clusters. It's really an effective means of managing Kubernetes in a much more scalable way. And so on the right is actually a full working example of what it is to actually run Kubernetes on both GKE and deploy resources into those. So this is an example in TypeScript. I import our libraries. This is my usual editor, right? Import the libraries in this case because it's TypeScript. I'm pulling these packages from Node. All of our packages for Pulumi, for the language of your choice, are deployed on the common package managers that you expect, right? We use npm for Node.js. We use pip for Python. We have our GitHub repos for Go modules. And so the pattern that you're used to working with the language of your choice translates very well to working with infrastructure and Kubernetes through Pulumi in this fashion. But as you can see, I have 40 lines of code. Like that's powerful, right? In 40 lines of code, I've generated a strong password based on an entropy library that we have. I've created a Kubernetes cluster with the latest release that GKE supports. I've passed my password into there. I've generated a kubeconfig based on this cluster's properties. In Pulumi, we have this notion of a provider. A provider for Kubernetes in particular is just a wrapper around the kubeconfig file. This allows you to share clusters across different programs. It allows you to share clusters across different teams. And it makes it interchangeable because you can just pass this provider in, as we'll see in a sec, how we can swap this out if you want to have repeatable infrastructure across different environments, different clusters. And so you can write the code once and leverage the use of it in many different ways. But this is pretty powerful, right? In 40 lines, I've found a namespace. We even created a new abstraction, which I'll get into in a bit, that allows you to write less code to create a pod, a deployment, and a publicly typed load balancer for that deployment for Nginx. So in 40 lines of code, we've already seen how much of this can be gained when you compare it to something like YAML manifest or extensive templates. So that's all great and dandy. So let's kind of dive into some more details, right? Like Pulumi is ultimately a modern infrastructure as code tool that is meant to work in many different environments, in many different languages, many different tools and environments. So we have many integration points with the common tooling that you would come to expect. No developer worked with the same stack, so we support various source code from GitHub to integration with VS Studio. You can leverage the many languages that we have for infrastructure code, and you can write your applications in the same languages as they would come, right? There's no need to re-architect your applications. This is really around the infrastructure. And we also have integration points with your common CI tools, your common package managers, and across the major cloud vendors, Kubernetes, and even on-prem installations such as vSphere and OpenStack. On the bottom is a preview of our dashboard, which I'll show in our demos. But you can start to see, right? Like you can see the actual diffs of what's changing on the left. You can then see in our console log an audit trail of who changed what. It'll point to the commit. It'll point to the diffs that are going to be actually rolled out. And then you can even drop down and see the resources themselves and go to the actual resources on the respective provider that they're deployed into. So really, it's about deploying code from and to anywhere. And Pulumi has many integration points already with these, so you don't have to start from scratch. So how does Pulumi kind of work under the hood, right? At its basic essence, and we'll dive into a little bit of the details in a sec, your user client is really where you author your programs and you run your programs, right? So I'll compose my Pulumi program in the language of my choice. The Pulumi CLI processes that program and then invokes the language runtime depending on the language that you ran, right? In this case, if I'm running Typescript, it'll spin up a node process and instantiate the infrastructure that I've described there. That in turn, all the API calls will happen from your client to the provider. So the Pulumi service, which we'll get into a sec. We don't see any of your user credentials. We don't make any of the calls on your behalf. We simply build the dependency graph of what your infrastructure looks like so we can declaratively roll that out and build it up. And all of these API requests happen from your machine, so we don't have to worry about privacy and security issues. Where the Pulumi service comes into is because we build a state file, much like Terraform has one, this state file is what we, by default, upload to our SaaS that allows you to do really a couple of things when you're working on the team. It allows you to do concurrent locking and state management of that shared state file. It does checkpointing. We have integration with our own config subsystem, secrets, so you can integrate many of these different components into your programs and make them templatable, right? If maybe you want to seed each program with a different random password or something to that effect. But more so, it's around using this with teams, right? So we have team auth, SSO, RBAC, and more importantly, a dashboard and set of workflows that helps you facilitate this. That's very analogous to our CLI. So that's kind of how Pulumi works under the hood. But if you do not want to use our SaaS, it's free and it's free for community users and it defaults to it. You can also store that state file locally, like in an S3 bucket or an Azure Blob storage or GCP Blob. But then you have to manage that state file yourself. But folks have been asking for that option to manage it themselves, and we've given them that feature. So we're proud that we have shipped that. So let's start composing. What is the Pulumi project? What's the Pulumi program, and how this all fits in? So a Pulumi program is the collection of your infrastructure that's running in the language that you've chosen: TypeScript, Python, Go, .NET. You write your program just like you would any program. And to instantiate it in Pulumi through the CLI, we have to create what's known as a Pulumi project. And all that's required to establish this as a Pulumi project is a simple file for metadata that allows the CLI to understand how to run it, and then the dependencies that you would need depending on the language of your choice. So I may pull in some Node packages, or I may pull in some packages from pip if I'm on Python. And this whole object itself is all that's required to actually run the program through your CLI. Because programs should be repeatable, right? If I stood up a particular stack, like let's say a Kubernetes cluster that has all the standards that I would want my cluster, I don't want to repeat that program over and over again, right? That's kind of what that's the movement we're getting away from. We don't want to generate templates. We want to be able to leverage programs and instantiate them. That's what stacks are. Stacks are instances of our Pulumi programs, and these are very analogous to your Git branches or your staging environments or your environments in general for how you roll out your programs today. So you can have a dev stack of the same program, and a staging and a prod, and you can tag these stacks to filter and search them easier through Pulumi. And what this allows you to really do is now have a holistic set of what your infrastructure should be in a given program, and you can just parameterize the variables that make sense depending on the environment or branch that they're living in. Stacks are also capable of referencing other stacks. So if I wrote a Pulumi program, let's say like my Kubernetes cluster in TypeScript, and then I wrote another Pulumi program in Python that stands up a managed database as a service, I can have stacks reference other stacks. So this allows you to decompose, to layer each of your infrastructure steps as you see fit. So you can imagine that if these were two teams, the left maybe our ops team who's in charge of instantiating the Kubernetes clusters, and the right is the application teams who's just allowed to deploy workloads into the cluster that we stood up. So you can start to segment this and organize this in however way you see fit and whatever makes sense for you and your team's structure. So really, Pulumi programs are a way of enabling infrastructure, right? You describe what infrastructure, what resources you want in your program, whether that be VMs, an object bucket, block storage, virtual network, or a Kubernetes cluster. And the CLI, what it'll do is ultimately create a state file that looks very much like what's on the right. This will ultimately reflect what's real in the provider of your choice, right? The API request will, if I'm saying I'm running on Amazon, will leave from my client machine. It'll instantiate the Kubernetes cluster and a VPC. And then the state file is what keeps track of what the current state of the world is. We have the ability to also fetch the current state, right? So if I deployed 2 VMs and someone went in to the dashboard on AWS and increased it to 3 VMs, I can do what's known as the Pulumi refresh to fetch the state of the provider, make sure my local state is reconciled, and then I can do any updates if there are any changes from there. But the code is the desired state, and that's reflected in our state file. Again, by default, the state file, we default it to running it on our SaaS. that's free for community users and teammates of certain sizes. But really, if you wanted to manage the state file yourself, you could do it locally. But then the onus of you managing it yourself and make sure that folks aren't stomping over each other on changes is going to be something that you're going to have to implement. So I wanted to just do a quick poll. I'm about to get into some of the Kubernetes aspects. So if those of you who would like to participate, I opened up a poll. You can visit pollev.com/MikeMetral75. This will help me just get a gauge for how folks have been working with Kubernetes, and help me kind of gauge the level of expertise that I can assume. So I'll take a minute or so for folks who want to participate to vote. Great, thank you. Okay, great. Okay, okay, great. Yeah, I'll just give this a couple minute or two. Okay, pretty even split so far. 0 to 3. We're seeing some YouTube chats also. Okay, some newcomers. Great, welcome to the session. Okay, perfect. Okay. I see we have some shifting changes. Okay, great. That gives me a better gate. And while I have you all, I'll do one more question just to poll the audience. It's going to be the same URL, but this time we're going to see what are you using to manage your Kubernetes cluster. So go for it. It's the same field. Should you see another question? Wow, quite a variance. Okay, so we have some folks in the cloud, a lot of folks managing this themselves on-prem. Wow, surprisingly, a lot more folks on-prem than I imagined. Okay, great, awesome. Well, that's all the work I'm going to put on you guys. Now back to me. But thank you for participating. This helps me gauge where folks are at. So let's jump into the Kubernetes pieces. This is a cake diagram, or really a diagram of many different layers that we like to use with Pulumi, because it showcases when you run Kubernetes in production. These are the various layers at its most smallest instantiation, what it looks like, right? You have to work with the provider at the bottom to instantiate the typical IaaS. Then you have to work with Kubernetes, whether it's managed or self-managed. And then once the cluster is up and running, that's where all the work really begins, right? Creating the cluster services that are general to the cluster itself, application services that service particular app needs, and the applications themselves. On the left, in the brackets, we've denoted the various Pulumi SDKs that you can use with each of these layers, right? So if I'm running on AWS, I can use the Pulumi AWS and AWS X SDKs to instantiate things like VMs, virtual networks, managed services, etc. And I can even leverage our Pulumi EKS SDK, which is an installer and a manager for EKS control points, and not only instantiates the cluster themselves, but starts to help you set up more of the features you're going to need once you're actually running in production. And once you're actually, so these are really about infrastructure and standing up the necessary requirements. This is really around the management of the control plane. But once the cluster is up and running, you now have to deploy resources into those clusters. So that's what the Pulumi Kubernetes and Kubernetes X SDKs are meant to help with. They expose the full API resource of Kubernetes, all the resources that you would expect, like deployments, services, config maps, secrets, those all exist. We just simply take the open API spec and basically extrapolate that and export it through an SDK in the language of your choice. So you can use Typescript to generate the same resources that you would expect such as deployment, config map, secrets, etc. So it's very much analogous to working with YAML or JSON, but you're doing it in a language. So you can see how this gets very complicated, right? But the proper approach is this should be a very layered approach that really defines the structure that you have in your teams, right? If there's operational teams who are strictly in charge of infrastructure, you can typically say that they'll be running the infrastructure and the clusters. Then you have maybe your developers who are deploying somewhere between apps and app services. And so you can segment these by different Pulumi programs. You can segment them by responsibilities. You can segment them by roles of people. But ultimately, as we showed with spec stack references, you can piecemeal this in different languages across different programs and construct the stack that makes the most sense to you. Let's jump into some demos. Enough slides for now. Okay, great. So everyone can see my terminal, correct? Yes, cool. All right, so I touched on some of these subjects. I'm going to cover some different topics here on how to use Pulumi with Kubernetes. So this is what a typical Pulumi program looks like. I have TypeScript. And in this case, I'm instantiating a GKE cluster. I'm giving it 3 nodes, giving it a username and password, and constructing a kubectl, and then I'm creating a namespace. And what you can see, right, is if I decided to, let's say, change this to, let's say, my apps, if I use the Pulumi CLI, I can say Pulumi stack, what's my current stack I'm in? All right, Pulumi stack ls, I can see all the stacks that I've created. If I do a Pulumi preview, because I changed the name of the namespace, you should see a rich diff of what's actually taken place. So it'll see that it'll actually change the name from apps to my apps. You may notice that there's this random suffix that we append to each of the resources. The reason we do that is because by default, we allow you to reuse these programs, right, across stacks. So more often than not, you don't want to use a static name to describe infrastructure that can coexist across many environments. It makes more sense to treat it more randomly, right? More like cattle than pets. Now, if you were really wanting to particularly say, no, the name of this namespace needs to be a fixed string such as apps, you can simply just do that by saying in the metadata of it to change that into my apps declaratively. But the point is, right, that you can see rich diffs of what's changing precisely. And if I ran a Pulumi up, it'll present me with the preview that we just saw, and it'll ask me if I want to perform this update. If I care to see a more richer set of details, I can see here's the exact property that's changing, what it's changing to, what's being added, and what's being removed. If I run that yes, what's going to happen is it's going to, Pulumi operates on the model where it creates a new resource before it deletes an old one. And it'll update any references along the way that may point to that. So what we first will do was create the new my apps namespace. Once that's working, we then confidently can delete the old apps namespace. And within a couple of seconds, hopefully, this should complete. But as you can see, we have these live updates happening with regards to how we're pulling the cluster using client Go in the background. The Pulumi Kubernetes SDK is that. It's a piece between client Go and the Pulumi CLI engine that knows how to retroactively construct these graphs, build them appropriately based on dependencies, and more so than not, allows you to reconstructively step through your infrastructure as the pieces and dependencies make sense. So this will take a couple little bit because I think I had an app running. That's why I'll cancel that, because I actually deployed an app into it. That's why it's not deleting. So I'll actually I can cancel this update. They already completed, but if we check out our nodes, let's see what our namespaces is. Yeah, so it's still terminating that old one because I actually have an application in the next console using that. So what I wanted to do was really kind of showcase, right? This is not just about deploying clusters. It's really about deploying applications as well. So I can, in my application, I have a new pane here where I said, hey, I want to reference the kubectl from this cluster, which I defined here, and I want to wrap it in a provider for GKE. A provider, again, is just a wraparound kubectl that I can optionally give it a namespace. So I can say, deploy this namespace along with this kubeconfig file, and this demo app should actively work with that actual provider. This demo app is actually a new class that we created here on the right. And this is just a new class that extends our component resource in Pulumi, which is really around allowing you to customize what resources should live together and be managed together. But I'm actually building a local node app using a Docker context path locally, so it can read my Docker file, right? If I look at the actual app itself, I'm going to the Docker file is here, right? It's just going to pull a local hello world and run it through Node. And what that's doing, it's actually building the image in this file, tagging it, and then pushing it up to the registry. In this case, it's GCR. I can then also describe, so in like 4 lines of code, I've built my image and pushed it and tagged it to a registry. I can also similarly create persistent volume claims, config maps, secrets, pods, deployments, and services in just a matter of a handful of lines of code. And this will actually create an actual application. So it's pretty powerful that I can use languages in this respect, because as you can notice, right, I can reference particular pieces that make sense. So for example, if you've ever worked with Kubernetes long enough, right, you have to pass in environment variables. And so you can reference these just because it's a language. Let's go into more detail on like how that actually works. So here's an example of the various ways we can use Pulumi with Kubernetes. We can deploy YAML manifests. We can use our Kubernetes SDK to deploy resources in the entire space of the API service area. And then we can also do the same thing, but with less code and less boilerplate using our Kubernetes X SDK. So let's see what this looks like to deploy YAML. Here I have a typical YAML file on the right. I have a deployment, right? I have a service, I have a config map, I have a secret, I have a PVC. These are standard file. If I'm in the process of, say, migrating from a YAML or JSON-oriented environment to potentially like experimenting with Pulumi, what I can do is I can actually leverage the Kubernetes SDK that I just pulled from Node. And in the Kubernetes SDK, along with all of the APIs like deployments, config map, secrets, we also have the ability for you to deploy a local YAML file. So if you were running this, we would actually have the case where if I do a Pulumi up, it's going to be a no op because I just ran this earlier. So it'll update this. Oh yeah, because I changed the provider. That's right. So do I want to perform this update? I'll say no for now, just so I don't want to break the demo. But here is the equivalent. So this is deploying in YAML, right? So if you don't want to fully translate all of your code from YAML to TypeScript or Python, you can deploy a YAML manifest to help you transition. But if you want to actually leverage the full Kubernetes surface area, here you have all of the kinds and groups in Kubernetes that you would expect, right? So this is spaced out depending on where the group and kind for the given resource lives in the API of Kubernetes. So you can deploy a config map, a secret, a persistent volume claim, deployments, right? And this looks exactly just like our YAML manifest, but we're doing this in a language, right? So to compare, here's what the deployment looks on the right in YAML, right? And this is what it looks like in TypeScript. Pretty similar, right? But now we're doing it in some languages. And this is great. We can immediately start to leverage the language to, say, do referencing of given objects, right, as you would expect, rather than trying to hard code our values. You can proactively extract pieces of information, such as the IP of this load balancer. You can wrap it in an interpolation to create a string. That's how we can create this output, right? That'll ultimately link to the URLs that we've deployed. But this is really the power of not just managing clusters, it's really about managing resources. And so you have the full surface area of Kubernetes to leverage. Just go and use the resource depending on where it's mapped in the same style as the API resource. We don't invent new nouns, we don't invent new resources. This is exactly what you would expect coming from the Kubernetes world. We worked very hard to make this as close to upstream as possible. Again, we take the open API spec and we just expose it in the language of your choice through a library. So we are not reinventing any of this. Or we actually have bots that every time a release is cut with Kubernetes, within about 20, 30 minutes, these libraries get updated with the latest specs. So we can describe our infrastructure, right? In this case, it's a typical app that deploys Nginx. But as you can see, we have 106 lines of code. This is a great start because it's programming languages, but we can do better. That's where Kubernetes X comes in. Kubernetes X is a helper SDK to allow you to use less code, describe less boilerplate, and still create the same semantic output type that you would expect, but using languages as the workhorse for doing a lot of the heavy lifting. So you can describe the same config maps, secrets, persistent volume claims, and using this new concept, we have a pod builder will actually construct the pod spec for you, and then you can reference that in a deployment and a service in 61 lines of code compared to 106 lines of code. So we've described the same application in using 40% less code than we did prior. So these Kubernetes X is really powerful because it allows you to really just get out of your way and focus on what makes sense. It's easier to maintain, it's easier to read, it's easier to manage. So this is a great utility for folks who are learning Kubernetes. A lot of our Pulumi users are still starting off with Kubernetes, and it almost makes more sense sometimes that the authorship experience reflects some of this, so you can see how these pieces can be composed, how you can stitch them together, and really what it is to fully kind of grasp the full surface area of working with Kubernetes, because it is just so vast and big. Let's move on to another demo I have. So here's a demo I have where I stood up a cluster in Amazon EKS, and I'm actually leveraging the ability to create an OIDC provider because I want to assign RBAC to each service account for a given pod. So I want to say, I'm going to actually deploy a Kubernetes service on EKS, and then I'm going to deploy a FluentD CloudWatch Helm chart, because Pulumi can also deploy Helm charts, using this cluster and the OIDC provider that we've created. Because EKS by default, for example, does not come with CloudWatch logs for your cluster. You have to bring this yourself. They recommend FluentD, and so let's see what we actually can deploy here. So in FluentD's class, right, more so, before I jump into that, right, it's because I have a language, I can have also my IDE yelling at me when I don't have the proper spec being mapped out. Or if I want to jump into the documentation, I can see all the documentation of the upstream library. Here's the type it's expecting. Here's more information on what this option is, some reference material. And it's pretty much like working with code. It's exactly like working with code, but for infrastructure. So this is pretty powerful stuff. If I jump into the definition of CloudWatch, right, which it's in this next file, I have a class that I've extended again for my own component needs, that's creating a service account. It's creating all the RBAC properties in Kubernetes, like cluster roles and role bindings, and more importantly, a log group in AWS CloudWatch to store all of my logs in. And deploying the Helm chart is as easy as using the Kubernetes SDK, and this time deploying a Helm chart to actually run our FluentD. One thing to note here is that our support for Helm started with early V1, and we never depended on Tiller. So Tiller being removed in V3 was not a big changer for us, because the way we use Helm here is really about taking the templates out of the chart and trying to render those on each of these objects. And so that allows you to get up and running faster if you just want to use a Helm chart that exists. But as you can see, right, when I describe the resources like I've done here, I have further fine-tuned control of how I can reference variables if I'm natively describing them in Pulumi, Typescript, or any other language for that matter. Helm charts are different because they're opaque. They're not as transparent, right? Because they're really managed as a single entity. So I can definitely adjust values, right? If I'm used to working with like the values YAML file to parameterize this, but I can also leverage transformations that allow you to retroactively transform something within the chart. But what happens is that the Helm charts are going to vary on a case-by-case basis on how easy they are to manage and how complex they can be, let alone how often they get updated. So most folks tend to actually fork a popular Helm chart, edit it themselves locally in a private repo, and then deploy it that way. So if deploying Helm charts is something of interest to you, we can definitely support that as well. So we deploy the FluentD Helm chart, and of note, we actually say, hey, in the RBAC values that we've defined here, you're going to actually use this service account we've generated for you. And why are we going to use the service account? Because we've bound this service account for FluentD to strictly only use the policies to work with CloudWatch logs the way we defined it. Here's where all that is done. So if any of you have worked with EKS requires that you have to have an OIDC provider, and you have to create an IAM policy that is particular to using what's known as an assume role with web identity action in the secure token service that they offer. In turn, what this is doing is if you have a pod and the pod is using a service account, it's going to auth against the OIDC provider to get a token saying, hey, this pod is valid, it's a real pod, I have its identity, and it'll exchange the token in your cluster's OIDC provider for a token in Amazon to run with the policies it needs. In this case, because it's FluentD, we're going to give it the logs permissions. And if you've worked with IAM policies in AWS, this is very analogous, right? I'm actually stringifying an object in JSON to pass in the policy where it's going to be able to control logs in the log group that I've used. So this policy allows me to not only get least privileged access to AWS credentials, but I can further tweak it by giving it RBAC specifications and saying that this can only be used with a particular cluster role that ties down these rules. And it binds that cluster role to the namespace in which this pod is running in with the given service account. So when I run this program, if I do a Pulumi update, because I already ran it, changes are idempotent. If there's no changes, you're just going to get a no op. So because I ran it before the demo started, we should see nothing changing here. And ultimately, once this completes, it say, I changed. Oh, funny enough, we actually just released. So this is one of the cool things about using programming languages. In the FluentD Helm chart, I'm pulling this from upstream FluentD on the Helm charts repo. They actually leverage an older API, right? Extensions v1 beta. And so in Pulumi Kubernetes, we can actually tell you, hey, this API group and kind is actually deprecated. You want to consider moving away to a more stable build so you can actually update it. So this, because I'm using this from upstream, I don't want to change that. So I'm going to cancel that, but I'll show you what the output of actually this is. So I can say, once I've created a FluentD Helm chart, what I want you to do is give me the log group name in CloudWatch where you're storing all of the pod logs, right? If I have all my pods, I want to see all of the logs for these pods. So if I do an output, like I've done here, I can get this auto-generated log group name, and I can go to CloudWatch and see what that looks like. And here are all my logs stored for my EKS cluster using code, using list privilege, and using an OIDC provider. So we can see how there's many different ways that you can leverage Pulumi to really work with Kubernetes, right? We've gone to the idea that you can leverage many different providers to create the clusters. You can leverage many different packages of ours to instantiate resources, build the Docker images, build the resources, deploy them into the clusters, segment this by the level of security that makes sense. We've seen how you can use Pulumi to deploy YAML manifest, to deploy Kubernetes resources, and to deploy Kubernetes resources using less code. And more so, you can see how you can use Pulumi to deploy Helm charts and all of the production needs that you would need to do to actually run an application in Kubernetes the way it should be, right? With proper IAM permissions, with proper security policies, whatever makes sense to you. And so these standards are really going to fall on you or your operational teams or your development teams to figure out what should a standard cluster look like? What should a standard virtual network look like? What should be supported out of the box day one, right? Something like a FluentD CloudWatch to expose logs, this should be built in. So maybe I start creating a new class where my clusters are automatically deployed with the FluentD CloudWatch Helm chart, just so I can allow them, my users, to actually use this. So I've gone through a lot, but need not worry. There is a set of links, and I'm going to be showing this whole doc with you all in the next slide. So there's plenty of getting started guides. You can get more information how to work with Pulumi Kubernetes here. We have production playbooks that are a set of Pulumi stacks that mirror each of these stacks in a segmented way that allows you to run Kubernetes in production. And we have already reference architectures for Amazon's EKS, for GKE, and for AKS that allow you to run Kubernetes in production with a reference architecture that's been proven and embedded through experience in the real world. And more so, we have an examples repo that has over 160 examples of all sorts of languages across many different providers, across many different use cases that cover infrastructure, containers, serverless, and Kubernetes. That's all I had prepared. So I wanted to open it up for any questions or any comments or any feedback if folks had. This QR code is a direct link to this slide deck. So please snap a picture if that helps. And here's some more helpful links for us to how you can help you and your team learn more about Pulumi and working with Kubernetes. And with that, I will take any questions.
Thanks, Mike. That was really amazing. Let me share the call URL so that people can join us for question.
Sure thing.
Okay, so let me check. So you mentioned that on the SaaS, it can take care of secret also. So is that can I use this instead of Kubernetes Vault Secrets, or is it complementary? Or
yeah, great question. So it's kind of twofold, right? You need secrets to kind of for the parameters, if you will, if you have different stacks for the programs. So we have our own essentially KMS, key management system, but that backend is pluggable to many different systems. So we support Google's, we support Amazon's, and I believe we also support Azure's. As far as Kubernetes goes, those secrets, right? That would be if you wanted to deploy a Vault or a KMS, that's going to fall on the cluster itself. So we have a good story around enabling a config subsystem and secrets within the Pulumi project. But then once you get to the Kubernetes cluster, you're going to have to figure that out with using something like Vault or any of the other secret managers that exist out there.
Okay, cool. And let me see.
I see a question about test-driven development. Yes,
Yeah.
so there's actually some great blog posts that I can link to that allows you to leverage the same unit testing, integration testing. We have some great mocking blog posts as well. If you just visit our blog, blog.pulumi.com, we actually just released a couple of these, right? We have policy packs, which is something I didn't cover. So just like you can describe infrastructure here, you can also describe policies, like saying in the language of your choice, no S3 bucket is allowed to be created that's public to the internet. Don't create a unencrypted block storage device, right? Don't create a Kubernetes cluster that has public IPs attached to the nodes. So you can use policy packs to enforce policies. But in this case, for example, we can even show how we can enforce resource tagging. But to the question about mocking and testing, right? Where is this blog post? Here, we have a couple of great blog posts on unit testing. If you scour through our blog, there's even more. We have something else in the works around how you can test and optimize Elasticsearch. But yes, you can do TDD in the language of your choice. You have to have like a seed file more or less that helps you kind of create a baseline for how to do testing done. But then you can leverage your usual utilities like Mocha, right? If you're working with those utilities.
Okay.
Let's see the next question.
Can this Typescript code have logic like pose and calling external API and await its results?
Yeah, so great question. So the way that Pulumi works is Pulumi is really an API of many APIs, right? So anything with a CRUD interface is capable of being leveraged. And so what we can do is if there's a CRUD API, you can actually create a provider, much like, just like Terraform has providers, we have providers too, so we can tap into the Terraform providers and leverage everything that has. But it's really just a bridge between our logic and just leveraging the ecosystem that exists. But we've had many applications in popular cloud native services that have wanted to create providers for Pulumi. And as long as there's a CRUD API, we can create a provider around that. And that allows you to make these external API requests to something that is not, say, managed by Pulumi. And of course, you can await its result because you have the language to actually leverage the async and await properties.
Yeah, makes sense. And there's another question about secrets. How do you manage secret for your clients if you have to create new keys, connection string, etc.?
Yeah, great question. So here, I hadn't gotten to it because I didn't know if we would have time, but
yeah, we have.
Perfect. So here is, well, let me just start with a simpler example. Here's the current project I'm in, right? I have an index file, which is my main. I have a stack name that's related to this file. I can see all the stacks that exist here. I can see Pulumi. I can see the config system, settings that I set, just as the region, right, that I want to run in. So to get into this, the secrets around this, I would say I can do Pulumi config help, and here I can actually set a secret, right, such as set secret. Let's say, sorry, let me make this a little bit smaller. Set.
You can hide the bar at the bottom if you want to.
Yeah. Yeah, it's not going away. Anyways,
there's a link that says hide in the sharing.
I see. Perfect. And when we actually set a secret, right, you can actually say, how do I actually set a secret? So I can say, set this secret, foo equals my password. Oh, sorry, I need to do, I think it's this. I forgot the command. So you actually see, so we actually do ciphertext on this, right? So you can gate so what this config management system really is a way to seed into the ability where, do I have a config file? No, I have a config file here. So I can say, hey, from my config, pull in a given parameter, right? And so I can seed secrets that way. If I wanted to put it on a per project basis, I can say, I can set secrets that way. But more so, if I wanted to do things like connection strings for like databases, right? What I really want, because I have languages, here's an example of running RDS. So here's an RDS instance. So RDS is a managed Postgres database on Amazon, and I can set a random password, right? A strong password, a typical username, some name for a database, and actually extract that property to create the Kubernetes secret with the DB host, port, username, password, and I can pass this object along if I export it to other stacks that want to reference it. So I don't actually have to concern myself with the details of what's actually taking place, nor expose that in any single way. And any property that is a secret in nature, such as the password, will automatically label the whole object as a secret, much like this looks like this. So you wouldn't be able to see, for example, like if we do, let's actually do that. Let's see what the example looks like in here. So I haven't exported that. Let me export this. So if I export it, if I do a Pulumi up, it'll say, hey, here's the new output. As you can see, this is the preview. Because we don't know what the output of this will going to be look like, right? It's like a future, it's a promise. So we, as a preview, will say, hey, this may change. But because we exported it, we know confidently that nothing is actually in practice changing. If I run the update, what's going to happen is that it'll just expose this when I do Pulumi. So see, even the metadata itself is confined as a secret. If I do Pulumi stack output, that DB connection will be hidden as far as the properties that make it sensitive. And I can reference this by saying, here's the stack. I can have another program say, reference my username with this program on this stack, and from this, get the object DB connection so I can use that DB connection in my application. All right, let's see what other questions there are. How do you deal with rate limiting Thunderbird problem, connection timeouts of the framework? Is it our responsibility to handle the retry logic, or the Pulumi framework has strategies? Great question. So we have plenty of retry logic at every step of the way, but ultimately you are going to be gated by the provider, right? If you're hitting the AWS, say, CloudWatch API too much, as can be done, say, with Fluentd, if there's lots of pods, that's ultimately something that AWS is going to limit you on. But we have retry logic where if I know that something is going to not necessarily work, let's say, let me break this, for example. Let me intentionally break this, just so we can see something actually not right. Let's say I created I don't know, I'm gonna change the version number to something I know does not exist for FluentD. I'll do an update, and it'll try, just like Kubernetes retries to run the program, it'll try doing that, and it'll continuously update you with any failed error messages or any status updates for that matter. So because the chart here is something we actually allowed to, see, it's not found. So I actually thought this is going to retry, but it's because we fetch it, it actually errors and tells you, hey, we can't find this, and then we're given raw repository. But if I did an even better example, let's say, trying to think of something on the fly here. If I wanted to say, here we go. In this one, this particular pod, in this particular cluster, I require that all, I have a pod security policy because I have a quota that says pods must describe how much requests they're using, right? So if I remove that, it'll keep retrying and retrying until I add that, right? And unfortunately, because I have a quota, or fortunately, rather in this matter, it won't let the pod actually come up. But you'll see that Pulumi will, so because remember, I'm building this container and it's updating it, but it'll continuously try as Kubernetes tries. So in here, because I automatically have the ability to push and tag images, I can automatically do that. But the spec changes on the deployment itself because we've told it to not have anything. So you see, I have these updates where it says, hey, I'm still waiting for this replica set to be available. I usually have to go to like kubectl to tell me what this is. When this does error out, we time out after about 10 minutes or so for most of the API resources. That's the default. It'll give you the actual output saying, hey, you couldn't create this replica set because of X reason. And in this case, right, if we were to, I'm going to cancel this just for the sake of getting to a demo. Oh, actually, so since I canceled it, it deleted it. But in other words, it said the pod wasn't able to actually come up because I actually have a lack of resources in its specificity. So Pulumi will constantly update that information for you, right, with any information it may have. And once it actually times out, in this case, 10 minutes, you can also make that timeout custom, right? If you know an object takes 20 minutes, you can certainly adjust it that way. What are the questions? Cool things. Thanks for the answer. Yep, great comment. Thanks for the answer. We are using Kubernetes in Azure. Last week we managed to automate some of this using ARM templates. How does Pulumi integrate with existing templates? Yeah, great question. So because we have no YAML, no JSON, no templates, right? It's really around that leveraging something like an ARM templates or a CloudFormation templates. That's just unfortunately not the path that we're going, right? We're trying to get away from YAML. We're trying to get away from JSON. We're trying to get away from DSLs because we ultimately are firm believers that programming languages are just a firmer and more proven tool for managing infrastructure at this scale. So I would say that we don't have a clear support for that. We are working directly though with a lot of the providers to try to have first-pass support for these templates, because we've gotten a lot of indication that folks may want to have more first-class support, right? Because if you're leveraging something like a Terraform provider that maybe hasn't been updated, you want something a little bit more proactive, right? As far as making sure bug fixes and API features are gated. So we don't have that, but we've heard that loud and clear, and appreciate the request. Awesome.
So you mentioned Pulumi Kubernetes and Pulumi Kubernetes X. So Kubernetes X is like a higher level API?
Correct, right. So if I go to the repo, Kubernetes X.
If I use Kubernetes X and that I realized later on that I need something slightly lower level, can I combine both? Kubernetes
Absolutely.
X and that's cool.
Absolutely. Yeah, so here, for example, here I import the Kubernetes SDK, and here the KX. I can mix and match this, right? Here I have a Kubernetes deployment from the actual Kubernetes SDK, and then further along is the same example in KX. But you can mix and match this, right?
Okay.
To some degree. That said, KX is still very early preview. We're still trying to get a lot of the stability worked into it. But for most general cases, it should be pretty effective. But you always have the original SDK to fall back to if KX just is too limiting for you.
Do you expect most people to be using KX in the long term, or?
So we would hope so, right? Because this is the equivalent of on the right, using the Kubernetes SDK is 80 lines of code versus KX is 40, right?
Wow.
Ultimately, yeah, it's more concise, and these create the exact same output types that you would expect. So you have savings in our experiment of at least 40 to 50% of the amount of code you have to write. Again, because the surface area of Kubernetes is so massive, you have to understand that it's very hard to find different ways to optimize it. But we like to say we are creating helpers to reduce boilerplate, because we're not trying to create a new noun. We're not trying to create a new way of managing this. Kubernetes is complicated as it is. We want to make the experience just a little bit more pleasant. And we think that Kubernetes X is in the right direction to help folks not only learn Kubernetes faster, but manage this and tame the scale with ease.
Okay, yeah. That's really great. We still have a few minutes. If you have time, do you want to show us the SaaS UI a bit so that we can get an idea of what it looks like?
Absolutely. Great question. So let me show you something. Let's see, something expansive. Let's see. All right, perfect. This cluster, Pulumi stack ls. I can go to my SaaS by just clicking on that. Oh, I have a question. What is Pulumi's relation with CI/CD? So Pulumi, much like you do Pulumi preview and Pulumi update, that is essentially we have integrations with all the CI/CD providers that I've listed here. All the major ones you would have come to expect: Travis CI, GitHub, Jenkins, GitHub Actions, CodeFresh, Circle CI. We have integrations with all of them, but they very much operate in the notion that you can do a preview. So when you create, like, say, like a PR, you can do a Pulumi preview, see the full preview, what's going to change. You can approve that PR or disregard it. And if you were to, say, merge it, you can have on the merge command, do a Pulumi update. And so you can do, we have a Docker container that allows you to get going, and we have integration points of all of CI to leverage this. We are very much in the mentality, Pulumi is best managed in the GitOps style, leveraged and managed by CI/CD. So yeah, great question.
If I have my own CI/CD and I want to add support for Pulumi, can I do it on my own, or do I need to get in contact with you?
No, you can definitely do it. You can definitely do it on your own. Our Pulumi Docker container is on Docker Hub, so you can just pull that and merge it into the CI that makes sense if we don't support it yet.
Okay.
But yeah, it's a Docker container that allows you to just kind of hit the ground running.
All right.
So the console, right? So I clicked the link here, and it took me to my console over here. So in my console, what I have is I haven't seen Bitbucket. Oh yeah, we do have Bitbucket support. That's probably not reflected on the slide, is it? No. Okay, no. We should probably add that. But yes, I know there is Bitbucket support. So Samantha, you should be good. On the console, right? This is the various stacks that I have for this particular cluster. So I can see all of the resources that I've created. This is the outputs. This is the configuration system, right? All this maps. If I do Pulumi config, these all map the same configurations that I have here. So you have an actual dashboard that it has this information. I can see metadata on the version control system being used, and then the outputs that I've created. Anything that I want to output to the user or to another stack, I would do it through an output here, right? This is how I would expose data that I care to share or properties that make sense. But more so, I can see an activity of, right, here's the actual commit, here's the branch I'm working on, here's the details of this update. Going to the update, I get timestamps, I see a full general overview of what's going to be created. You can get these same exact outputs in PR comments when you do a preview, so you can see the full spec of, right, of what this looks like if you are using CI/CD. I can see the full diffs if I want the full actual diff of what's being created. I won't bore you guys with those details, but more so, you can see a timeline of what's changed, when it changed, who did what auditing aspects. You can see the environment information. You can see policy packs. If I have policies that I want to enforce at this stack or at an org level, I can define them here in the language of my choice. And I can see a full resource list of what's being created in this stack. So I have everything from the namespace that I'm creating, the resource quota, the cluster itself, the security groups for EC2. And I can even see this in a nice little kind of dependency graph that allows you to kind of zoom in on kind of the dependency tree of what this all looks like, right? You have the stack, then from the cluster, you have any dependence on that cluster. I can actually jump into, say, like the EKS cluster itself. I can then view the security group in AWS by clicking a link, right? And it'll take me directly to that resource and see that resource in actuality. Same thing for, say, right, like the cluster, and in Kubernetes where it's supported. But more so than not, right, this allows you to not only visualize, but manage and really have a dashboard for information and control flow around who did what. And you can gate all of this with RBAC. This is analogous to gating the same RBAC as you would with the CLI. They're one and the same. But it allows you to have a UI for folks who are more information driven, who are more dashboard driven. And we're actually considering trying to figure out how we can implement certain workflows for folks who may not want to necessarily drive everything through the CLI. So this is a great utility. We automatically, yeah, go for it.
So right now it's read only, but you plan on allowing people to write stuff with it, write workflows in the future?
No, it's not read only. No, this is definitely. Oh yes, read only in the dashboard sense, right?
Yeah.
Yes, exactly, correct. And in the future, yeah, we are working towards how to identify workflows to help this out with this stuff. But in the CLI, right, if I create a new project, we have some of this built into the CLI. Push the Pulumi, do DevOps. I can do Pulumi new, and it'll give me a template system, right? Like I want to do, AWS Python, DevOps name, blah, 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 give it a stack, dev, region, I want to do, say, US West 2, and now you have an actual template.
So that would be like doable from the dashboard?
Right, so equivalently, right, something like this will be something we're considering. We're still trying to figure out the schematics of what works there, just because it's as you can imagine, it's very complex to kind of find a common ground that works for everybody. But the templating system is a good starting point. And just like this, I can create any project that I would like by using the template system. And you can build your, oh, it's already created one. You can create, I think DevOps too. And you can create your own templates if you wanted to template it that way. I see we have some questions.
Yeah.
But I understand we can use Docker in the pipeline. If there's an error when allocating a resource in the group start failing, does it support rollback? Yeah, so because we like to drive everything through Git, we say you don't roll back, you roll forward to a new commit. So on a change or on a fix, if something were to break, you would just you would do the change to. Oops. Sorry, I lost my desktop. You would choose the commit that makes sense, and then you can just roll forward and do a new update on that commit. So there's no sense of truly rolling back, you just roll forward. Terraform has a remote backend, S3, to store state file remotely. So you have something similar with Pulumi in order to avoid concurrency access and resource changes. Yes, we do have your own remote state backend. So in this diagram, by default, we attach it to the SaaS just so you can kind of get up and running to store the state file, right, that we described here. But you can also take that state file and store it yourself locally on S3, on an Azure Blob Storage, or on GCP. But the benefits of doing it through the SaaS is that you get automatically state checkpointing, concurrency locking, so that when you work on a distributed team, you're not stumbling over the changes. When you want to manage it yourself, either in a local file system or in a blob object storage, you're going to have to manage that state file yourself and who has access to it, and ultimately that updates aren't concurrently happening and affecting each other. So yes, you have the ability, but you're kind of taking a self-adventure in that path.
Okay, no more questions, it seems. Does anyone have any more questions? You mentioned that for people who do not or cannot use the SaaS, that they would have to re-implement state. Could you tell us a bit more about this aspect?
Yeah, it's not about re-implementing state. Sorry if I said that. You have the state file. You have to basically have a while to manage to concurrently lock that file, because what's happening is when we are actually working through a program, like let's say this one, right? We're building out like an entire graph. And that graph is kind of going to depend. Its reality in the world is going to depend. What does that look like currently in your provider of your choice, and what does that look when you desire it to be in a different state. So the state file itself, you will always have. It's just a matter of where that state file lives and how that state file is managed. So if you choose to manage that yourself locally, you then just have to have essentially a read lock or a write lock, rather, both on the state file itself if you did not use the SAS. So the state file always exists. It's just a matter of protecting the state file.
Mm-hmm. Okay. All right, I think we're done with the questions. I don't want to steal any more of your time.
Oh, no worries. Glad to do this.
People seem to enjoy it in the comments.
Great. Yeah, please visit the links. If you snap a picture again, it'll take you to the slides, so you don't have to hurry and write a bunch of notes. If this is interesting to you, you want to learn more, you can follow us on Pulumi Corp on Twitter, Pulumi on GitHub. My name is Mike Metral, and if you can also reach me at, if folks have questions, you can also reach me at mike@pulumi.com. Yeah, I hope everyone learned something. And I haven't touched Pulumi yet, and I'm considering using it for my team. How steep is the learning curve? If you've already worked with infrastructure as code to begin with, say CloudFormation or some sort of templating mechanism or Terraform, the learning curve is really not all that different. It's just a matter of learning the language that you're going to be operating within and how that kind of balances between the infrastructure as code. But we have, again, 160 plus extensive examples, easy stuff, medium and advanced, covering all sorts of topics that should help you start off in a much better point than trying to do it yourself. So if there's any questions, please open it up. And we actually have a vibrant Slack community, specifically the Kubernetes channel, if you're interested in Kubernetes. We have thousands of users where the entire team jumps in and helps, as well as the community helps one another out. So if you ever find yourself stuck or needing assistance, that's the best place to find support. And the examples that are linked here are a great place to start on the provider of your choice. And I encourage you to take, to visit these slides so you can process this information at your own leisure and when it makes sense to your schedule.
All right. Okay. Well, do you have anything else you would like to tell us, or?
Yeah. So I was going to say, hi, folks, folks on team on camera. The learning curve to working with Kubernetes is high, right? As we saw with many folks it seems like many folks are starting off with Kubernetes. This is hard stuff. The idea is to minimize the footprint required to get started to the point of the question just asked. And languages we feel is a good starting point to help reduce boilerplates, to avoid the copy pasting, and to leverage the construct of programming languages, loops, conditionals, abstractions, IDE tooling, error checking, linting, right? That's really what a lot of that is premised on. But the architecture playbooks, for example, that we have with Crosswalk for Kubernetes is really where the work begins. It's easy to say that once they stand up a Kubernetes cluster in particular with like Amazon EKS or GKE, the work only starts there, right? Because you have to make these clusters multi-tenant. You have to make them ephemeral if you want to test live changes. You have to make them compatible to many different types of users. This stuff is hard, and not everyone knows how to do this. The documentation exists. There's plenty of materials, but if it already exists in code, it's a greater starting point than trying to manually recreate tutorials, right? We have many examples where we've shown tens of thousands of lines of YAML being done in 400 lines of TypeScript, and the power is really quite there. So I would say feel free to give this a shot. It's completely free for community users for life. Again, we're open source, Apache 2. Where we have our business model is really for teams who are operating on an org mentality. Very analogous to kind of GitHub, right? You have Git is the Pulumi CLI and GitHub is our Pulumi SaaS. The SaaS very much operates in that model. It's free for your general individual users for life, and teams is how we have a monetary baseline for it. But it's really around leveraging the hard work that we've already done to get you started, because this is hard. This is difficult. Nobody knows the full extent of all these languages, let alone every cloud and how these pieces mix and match. And then once you actually get into Kubernetes, it's a whole different world. So leverage the resources that we have, leverage the examples we have. Please feel free to contact us on Slack. We also do office hours twice a week now where we open ourselves up on a Zoom chat for folks to field questions. We just had one a couple hours ago, EU on the EU time zones. We have on Tuesdays at noon, or rather 11 a.m. CET, we have our EU office hours every Tuesday. And on Fridays at noon Pacific time, we have our US office hours. I can share a link with Patrick for folks who want to follow up, but it is the office hours channel
Okay.
in Slack. So office hours. That is a great spot if you want more kind of live one-on-one with us, and that'll kind of help you get going.
All right. Well, thanks, Mike, and thanks everyone for watching.
Absolutely.
And well, see you soon. And
thanks, folks.
Let me know if you want to do another hangout one day.
Absolutely. Absolutely. Thanks.
All right.
Have a good one.
Cheers. Bye bye.